Hello everyone, this is Team 12 and I am Akila Gorkala. So, this is a team project for SER502 Spring 2024. So, our language that we designed, we have named it as EnigmaScript. Next page. So, coming to the introduction to EnigmaScript, we have created a language EnigmaScript that adheres to specific constraints by ensuring support for basic data types, assignment operators, conditional and looping constructs, and output capabilities. So, this Enigma script was created with an open source philosophy and utilizes the synergy of cutting edge tools such as Antler for parsing and Java for runtime. And we also use the other tools that are IntelliJ and GitHub. So coming to the next slide. So the next slide is about the life cycle of Enigma script. So in this Enigma script, we start with the source code, which is meticulously broken down by Antler that are chosen lexical analyzer into the tokens. So these tokens are like the building blocks of the language, capturing the essence of the code. And the next, the parser takes these tokens to construct a parse tree, organizing them into a structure that represents our code's logic. From here, the code is translated into an intermediate form, a universal coding language ready for the interpreter. And next, the interpreter then executes this code, resulting it in a final output. So this end-to-end process showcases the efficiency and synergy of EnigmaScript's design, transforming the written code into an actionable results. So the next part is taken by my friend Ujita.
Um, yeah, now I'm gonna describe the above flowchart that is mentioned by my friend Akila. So the life cycle of Enigma script consists of several stages: source code, lexical analysis, parsing, intermediate generation code, and interpretation and compilation. So coming to lexical analyzer, also known as Lexer, plays a crucial role in process of compiling and interpreting the program. It is also responsible for converting raw code into sequence of tokens, which represents the basic elements of the language that are identifiers, operators, and symbols. Lexical Analyzer simplifies the parser's task by providing clean, organized token. Um, and it can also discard irrelevant components such as white space and comments. Next, parser. Parser is a key component. Um, It analyzes tokens and builds a parse tree, ensuring the code conforms to the language syntax rules. Um, Coming to the next slide, compiler. The compiler transforms the high level language into an intermediate form understandable by the machine. So during this compilation process, the compiler checks for errors at multiple levels such as lexical, semantic, and syntactic. Next is the interpreter. Interpret the compiler transforms the high level, and then next interpreter executes the Enigma script code, providing a runtime environment for testing and debugging. It also provides the includes handling inputs, output operations, and code and ensures that the code is running correctly or not. Next slide. Here we have included many features in our Enigma script that are data types, Boolean, integer, string, arithmetic operators such as addition, subtraction, multiplication, and division, comparison operators like greater than, less than or equal to, inequality, greater than or equal to, and logical operators and or not. Next slide. Assignment operator, equal to and not equal to, ternary operator, um, condition, unitary operator, increment and decrement, iteration blocks, while, for in the range, conditional blocks, if else, and else. Next slide. And for the standard output, we have included the print statement. For the comments we have mentioned in the grammar, we have used the symbols, and identifiers we have used caps and smalls and numbers from 0 to 9. And in the slide they have mentioned all the symbols that we have used for the operators. Next, my friend Saumit will continue describing about the grammar we designed.
Hello everyone, I'm Soumya. So I would like to explain the grammar logic right now for our programming language. Our basically according to the grammar, it is defined that our program starts with the keyword enigma start and it ends with the keyword enigma end. Then we define the block called command list that holds upon one to many commands. In a enclosed inside the flower bracket. Then for the command block, we can have enigma if command, enigma while loop command, enigma for in range command, enigma for loop command, enigma print command, and enigma print assignment command. So the print assignment command basically sorry enigma assignment command basically is part where we are defining how an integer is equated or initiated. The first line integer enigma underscore var equate num expression question mark says that we can either initiate the integer variable with integer enigma, or you can give any number equating it to it. So the question mark stands for 0 or 1. The same goes with the boolean and string. Then with the second line, integer enigma variable equate enigma ternary assignment. That line is used for giving the logic of how you can use a ternary assignment just like in Java. Then the conditions, we have two conditions, that is number expression and Boolean expression. Number expression is when you go further down, you can see number expression is when using two variables or numbers to comparing with the symbols like less than, greater than, or equal to, less than or equal to, greater than or equal to. Then the Boolean expression is where we are using the logical and, logical or, equals and not equals between two Boolean expressions, or when we are using a negation of a particular Boolean expression. So then if we go further down, the evaluation expression, we use the parenthesis, the normal brackets, that contains the Boolean expression for the evaluation expression. Then enigma if command states that we have to use the keyword if at the starting of the command. Then we can define any evaluation expression or the command list. These were discussed on the top. So enigma if else command can be mentioned, or it may not be a necessary case. But the star symbol indicates that this particular block can be 0 times, or as many times as possible. You can be used in the for the program to be semantically correct. Then the enigma else command can either be used 0 or 1 time. So you can either put it or you can exclude it. Then it ends with the ending keyword end if, end underscore if. Then the enigma if else command starts with keyword else if, then the evaluation expression and the command list, what all commands to be executed, then the end else if. The same logic goes with enigma else command, where you give the else, then you give the command list, then you give the end underscore else keyword. Then enigma while loop has the keyword while, then you give the evaluation expression, the condition for the while loop to be true, then the command list that have to be executed, and then end underscore while. The print statement has two different ways to put it. The printing of a string uses at the rate symbols in front of it, just like how double apostrophes are used in Python. And for printing any variable value or any integer, you can just uh, print it just by stating out the expressions of the variables basically. Enigma for in range command starts with the keyword for, then you give the variable that is measured for that particular equation. Then you give the range of that variable from what is the starting range and what is the ending range. Then you give all the command lists that are need to be executed for that particular block. Then you end it with end underscore for. Then in the range value, we use either a variable or an integer, anything, both comes under range values. Then for the decrement operator, we use minus minus. If it is used after a variable, that means the decrement is happening after that particular line is executed. If we are using it before a variable, that means the decrement has happened just even before the execution of that particular line, and then it commits the execution of that particular line. The same goes with the increment operator. Just decrement deals with -1 and increment deals with +1. Then the Enigma ternary assignment deals with the same as in Java, where you enclose the if condition into a single line condition. If the condition is true, the first statement is executed. If the condition is false, then after the issue symbol, the expression after the issue symbol is executed. Then all the string integers, boolean values, and all the addition, division, all these symbols are explained by my friend Ujita before. So continuing that, Hemant will take on right now, explaining all the runs and programs. Thank you.
Yeah, hi, this is Hemant. So right now I will run some few sample codes for the previous defined grammar. So let me show you the grammar. Okay. Okay. Yeah. So right now my file is .ex file. So this is the basic file which I will be presenting. So yeah. So in this file, I have used some assignment operators and basic addition, subtraction, and division, and print some basic print statements, which contain both string and both variables printing the variables, and basic if-else commands. And I also used bool commands and logical operators also in this sample. So let me execute the sample. So the main thing about executing the sample is that the jar file and this .es file should be in the same directory. So, and you need to open the command prompt at that directory. So after opening the command prompt, you need to use this command. So yep. So again, let me show you the code. So we can see that what is printing about here, like print about A addition B and its output, its value, and similarly the if conditions and the Boolean values respond according to the condition satisfying it. And also I've printed at the end I have printed a string. So this is one of the sample code. Let me show you the another code, which is yep. In this code, I have wrote command program for loop and while loop and for in range command to print some basic values. So let me execute the code. So yep. So you can see that for the first one, for loop is printing from 0 to 9 as it's initiated from 0 until it's less than 10. So that's it. And while loop is should be like greater than 5. So because here's the value is 9. Uh, the I values goes to 10. So it starts from printing from 10. So whereas the foreign range loop starts from 10 to 15. So here it starts from 10 to 11 to 15. Yeah. So the base value doesn't comes in the print statement. And the third one is about if conditions, if else and else if conditions. So this is the defined grammar, like if and else if also is there. And to end the else if you need to write and else if, and to end the else condition you need to write and else. So let me execute the program. So you can see that right now A is less than B. So you can see that A is less than B is printed. If you modify the code and again execute it, you can see that A is greater than B. So if you give same values, it's going to be as A is equal to B. It's going in this condition for the last one. So yeah, and for the fourth sample, I have wrote a basic ternary operation. So here A is assigned with 10 and B is assigned with 1000 value. So by the above logic, A is less than B, so it's follows. So the B value is getting stored in C. So let's execute and see the output. See, B value is stored in the out C. So that's what happens. Let me change the code so and let me execute it again. So you can see that A value is being stored in C. This is the basic ternary operation. So again, we have wrote this factorial code in many languages previously. So I thought to again write it in again in EnigmaScript also. So let's execute the factor. Yeah. So here the number value is 5. So as we all know, the 5 factor is 120. And if we change the value again, it's gonna be. So yes. Yeah, with this concludes my sample runs of the Enigma script. So thank you again.